Well, first of all, thank you so much for coming. Thank you for attending this. It's really exciting to see everybody here and talking about FreeBSD and all of the cool things that are going on. Thanks for having us. This is Jerome Roussin, and I'm Phil Ezolt. And if my face looks familiar, I saw some of you guys in Ottawa a couple years back talking about a different part of my job. But in this particular case, we're going to talk about how NetApp has used generative AI to kind of accelerate some of our development processes and how we create software. So Jerome and I are both part of this group called the HCPE Engineering and Tools and Services team. And this is kind of like a team that is responsible for a lot of kind of how the sausage gets made for our products, particularly ONTAP. So the infrastructure, the tools, whatever that people use to build the thing, to test it, to maintain the quality, all of that stuff is kind of flows through our group. And so we have this charter to both make developers more efficient, but to also try to protect the quality and increase the quality of our products as time goes on. And so really, we have this like centralized view of all of the different, a lot of developers that come into our tooling. And so if we find places that we can add things that make stuff faster, higher quality, that's what we want to do. And so about 2.5 years ago, when the senior VPs came to Jerome and I and said, hey, there's a lot of really cool stuff going on around AI and generative AI. How can we use this to make better products for our customers? So the kind of outline of this talk is going to be about the kind of state of the world for Gen AI, how we have applied it for different things we make in NetApp, and then finally the lessons that we've learned that hopefully will apply to the FreeBSD community, and you guys don't have to learn the same lessons that we learned by bashing our head against the wall again and again. So with that, I'll have Jerome take it away.
Hey, thank you. All right, so I'll start with some history on AI in general and coding LLMs in particular. That's what really is interesting to us in the group that we are in is models that can read and write code, right? So if you look at history of AI, really the birth of the major models or generative AI models, 2018 was GPT and BERT, and very quickly GPT-2, and then a whole bunch of others. But what really got us excited is in 2021 when OpenAI came up with Codex. Codex was the first model that was trained on a whole lot of GitHub projects. And so it had coding capabilities. Pretty basic at the time, but already exciting. And so we got beta access in August of 2021 and then started exploring what we could do. The very first thing that Phil did was creating a little tool that could translate, or try to translate one of our shell script into Python, I believe, right? And we got, it got more exciting from there. And then in 2023, GPT-4 came out. And GPT-4 is a big deal because it's the first, they call it human level. I'll get to what that means in a minute, but they call that human level coding skills. And in March 2023, it was a very busy month for us. We got GPT-4 access, we got Azure OpenAI access, and then ChatGPT came at the same time. So all of these exciting things happen all at the same time. And ever since, the ecosystem around AI has been growing, whether it's new models, new ways to host it, deploy it, libraries. I put some logos on there, right? It's very hard to keep up, frankly, with what's happening. Okay, so at OpenAI itself, however, let's talk about that a little bit. So we saw the evolution of OpenAI models. So the first thing, again, that got us interested is when those models got better at coding, right? So that's Codex, somewhere in the middle here in 2021. And then what we saw, so Codex was a little, again, pretty basic, and it was really a true completion model where it was hard to tell it exactly what to do. It had to infer what to do based on the previous stuff in the prompt, in the context, right? But we could still do a lot with it, right? We figured out it could do documentation automatically. We figured out it could do translation, somewhat okay. But for things that were more sophisticated, it would not necessarily follow instructions very well. That came later. Instruction following came in TextDaVinci. Can't remember if it's 03, probably 03, or 02 or 03 got better at following instructions. And then what became easier to do too is to have the model better understand follow-ups. And that was the whole chat model, right? ChatGPT came out, and now you could have this dialogue between you and the model about code. And that turned out to be a way to get much better results, and I'll talk about that in a minute, how that's a particularly useful way to interact with coding models. And then a bit later, those models, some of them got really cheap. So 3.5 got really, especially 3.5 Turbo got really cheap. So that really expanded what we could do with our limited budget. And ever since, OpenAI seems to have spent a lot of energy on their ChatGPT offering, ChatGPT Plus offering. So the gap between what's available in the API and what's available via ChatGPT Plus has been growing, sadly. All the recent announcements from OpenAI around plugins and multimodal isn't yet available to API users. Okay, all right, so let's go back to GPT-4 for a second and why we were excited about it. So I have a link here to the GPT-4 paper. If you've never seen those graphs, there's a whole bunch of more of them in the paper. So they describe how GPT-4 has human-level skills in many tasks. So what you're looking at here is a graph that has, on the x-axis, a number of exams. So it's a number of AP exams, physics, history, and so on, GRE, and whatnot, a whole bunch of them. And then the x-axis is results in percentile among exam takers. So this isn't how many questions the models got right. It's how well it compares to other humans who took the same test, right? So a 90% result means that GPT-4 scored better than 90% of the humans who took the same test. And supposedly those humans are not taken at random. They've studied for the test, right? And so what you see here is how many different topics the model is decent at, right? It scores in the above 80 or above 60 in a lot of them, especially GPT-4. GPT-4 is the green bar, GPT-3.5 is the blue bar. And so GPT-4 is not superhuman in any topic. You can see it never actually beats all the humans, right? It never reaches 100 in any of those exams here. What makes it a bit superhuman, obviously, is the breadth. It's rare that a human would score that well in all of these topics at once. What makes it really the key differentiator between GPT-4 and humans is the breadth, the speed, and the stamina, right? It's not going to get tired of answering your questions. So all that I'm showing here is non-coding exams, and I'm going to go through coding benchmarks, which is really what we're after here, is how good is GPT-4 and 3.5 at coding. So I'm going to show you a few more the next few slides here. Right, okay, so I also want to say here that, okay, hang on, I'm going to go with this slide first. So here is GPT-4 against other coding models and specific two benchmarks here. Human Eval. So Human Eval is an OpenAI benchmark. It's a Python benchmark made out of 160-ish problems. And you'll see Human Eval used regularly as a way to measure how good models are, right? But just so you know that it's not a pretty basic set of problems. And so in this paper here, and I put a link, they created this other benchmark called Class Eval, where they made it a little harder for models to get answers right. And so there's a few things here to observe here. Right? You can see, the first thing to see is how GPT-4 has the best results, right, regarding of which benchmark we're talking about. But there are others, right, that are not OpenAI related, and I'll get back to this in the next slide. And the other thing to see here is that look at the very first set of columns, for example, right? So the human eval result is 85 for GPT-4, but the class eval is only 37, right? So those models are not by any means perfect, right? It's very easy to trip them up. But they've got to a point where they can be useful, right? And we'll show you a bunch of examples of how to make them useful to you. All right, so I'll go back to the previous one. So this is another set of benchmarks with a different set of coding models. All of these are available on Hugging Face. If you don't know Hugging Face, it's like the GitHub of AI. And they show here the results for these models on human eval, again, and then another benchmark that we call multiple E. And multiple E is 18 language, and this time more than 160, more like 1,000 different Python problems. Right? And there are a few things here to see in that graph. So, all right, let me explain the graph. The x-axis is the score on a particular benchmark. The y-axis, the x-axis is the throughput, meaning how fast the model is at answering the questions, right? And let me point out a few things here. And the size of the square is how big the model is in number of parameters. So what you can see here is that the bigger models, so the bigger square, are higher on the y-axis, so they score better, but they're also slower. Right? The other thing to note here is how Code Llama, that only came out in August 2023, how it's dominating those benchmarks. Right? A lot of people taking what Meta did with Llama 2 and Code Llama and fine-tuning, creating fine-tuned models and making them pretty good. Right? What you'll see too here is so the sizes go from what? Yeah, here on this particular example, 35 to 7 billion parameters. And you might wonder, why create a small model at 7 billion if it's not going to be very good? And the answer is, I can tell you now, it's because they're faster. It turns out that speed matters for some use cases, and I'll get back to that. Okay, so far, though, the benchmark we looked at, whether it's human eval or class eval or MVP, are benchmarks that look at models, what models can do in a single attempt. Right? So there's a problem. It's sent to the model answers, and then it's evaluated. Right? But it turns out that that's not how humans interact with models anymore, not when you have a chat interface. When you have a chat interface, what happens very quickly is when the model does not answer properly what you want, you usually tell it what it did wrong. So you either include the error message or you include a few more instructions you forgot. You start having this dialogue, and then eventually the model, typically, if it's doable, gets it right. And so I found these benchmarks here. This one is called Mint, that looked at multi-turn. And by that, I mean asking the model, giving the model several attempts to get a question right. So that's what you're seeing here. Each line is a different model. The y-axis is the success rate or the score on a particular benchmark, and the x-axis is how many attempts it took. Right? And so there's a few things to note here. The first one is how almost all the models go up and to the right, some more than others. Right? In other words, again, the more attempts you give a model, the more feedback you give a model, the better it does. And that's a very common experience once you start creating AI apps. You quickly realize that you have to have a multi-turn. You have to give the model several attempts when it does it wrong. You have to provide the output of what happened, and then it gets better that way. The other thing to note here is that line on top is GPT-4, right? GPT-4 at k = 5 is way above everybody else, 69, compared to the next second is Claude, interestingly enough, right? And the reason, again, why this happens is because you may have forgotten to tell the model something that was very important to answering the question, right? Or maybe the task you gave the model was a little too hard and it couldn't do it in one bit. It's going to take a few steps to get there. And And it turns out that decomposing a problem and creating the proper prompt or set of prompts is prompt engineering, and it's what you end up spending your most time on when you create an AI app. Okay, and another benchmark here for multi-turn called intercode. It shows that effect even more. Look at on the right here. Look at the blue line. As soon as here it's GPT-4. As soon as GPT-4 is given a few attempts to do here, it's a SQL problem. Immediately the scores shoot up, right? So that's the lesson here when you're dealing with AI is you may have to give it multiple attempts. You may have to refine your prompt. You may have to provide some feedback as to what happened on the previous steps. And the more, by the way, the more you can actually code that up, obviously, the less a human has to do it himself or herself, the better. OK, now let's go back to the model size and the model speed problem. So what we've seen so far are Python benchmarks that are not completion. There were questions in Python. There was usually function generation. But a very important use case with AI is AI code completion, right? So you're typing, you're writing code, and then a model will suggest the next few lines, or maybe the next word, usually a line or 2 or 3 or 10, right? And for that particular use case, speed matters now, right? Because a user isn't going to want to wait 10 seconds for that answer. And at the same time, the problem is a little simpler, right? The user just wants a few more lines, right? They're not trying to create a whole function. They want just 3, 4, 5 lines. And for that, GPT-4, even though it's great, is a little slow, right? And so none of these solutions that I put on the right here, it's only some of them, by the way. I'm sure I know there are way more than that. Those are all code completion solutions. None of them use GPT-4. GitHub Copilot actually uses Codex. I don't know what Amazon uses. Replit uses their own model. SafeCoder uses StarCoder, and so on. They all use smaller models to do code completion because of the latency problem, right? And so what's exciting here is that competition can happen at a much lower size for the models with way fewer GPUs, and so you see a lot more players in that space. Like I said, I have 6 here, but there is probably double that number, right, in reality. Multi-turn is not desirable in that case. The user wants the faster the better, basically, for AI code completion. The challenge with code completion is that your project code spreads multiple files. So there's significant prompt engineering here required to create the prompt with all the context required across multiple files to get those few lines. So it's a completely different use case than just the human eval benchmark, the code eval benchmark. OK. So in summary, in terms of capabilities, GPT-4 is king for now, right? So if you're watching this on YouTube, this may not be the case anymore. But today, in November 2023, that's the case, right? Another takeaway is, again, multi-turn interactions and prompt engineering lead to better results, right? If you don't get what you want the first time, maybe you forgot to include some critical information. Maybe you need to try again and let the model have multiple turns. Another takeaway is a lot of stuff is happening outside OpenAI. OpenAI isn't the only name, but all that competition happens at a smaller model size, but that's OK because AI code completion requires smaller models anyway, faster models. So we're excited about all that. Now Phil is going to show you a demo of the playground we've got.
OK. Yeah, so early on, all this cool stuff that Jerome was talking about came into the picture. Oh my gosh, this stuff can code. It does a pretty good job. But like anything, there's hype and then there's reality, right? So what we wanted to try to figure out is, OK, this is all great and cool, and this is here, that everyone's excited about it, but can it actually do anything to solve our real problems, right? So, and Jerome and I can't see what all the different NetApp engineers would need to do, or we don't understand their jobs and their problems and things like that. So the goal with this thing, which we call the playground, was to try to put these tools in the hands of our engineers. And I'm going to give you a demo of it, so that they can play around. And some of the stuff they did is totally nothing we would have ever designed for, which users, right? So we have this thing that, again, here's the playground. So the user kind of presented with this prompt that basically allows them to interact with it. Now, if you've used ChatGPT, you've seen something similar. The one thing that's really powerful about this is, and we'll talk about this in a second, in a few slides, is that this is backed by Azure OpenAI. It's completely under NetApp control, so we don't have to worry about whatever our NetApp people type in going out and being used to train other models or going to our competitors or things like that. So we have this environment where basically users have these prompts, right? So the straight out of the gate, one of the fun things to do is is just ask it a question and have it create something for you. Nothing to do with code, but just give you an example of like what it can create out of whole cloth. So I'm going to say, why is FreeBSD the coolest kid on the block? And it will go off. It will think a bit. It will go to our instance of OpenAI running in Azure, and assuming it works as well as it did, here we go, okay. It will come up with some answers, and then it'll be diplomatic about how you can't really, who's to say what cool is, right? But, and this, again, this is with the most recent GPT-4 model that Jerome is talking about, but it's going in and it's telling you, here are all the things that are really, really cool about it, right? And, you guys would know much better than me, but I would agree with a lot of these things, right? And so, and if it's wrong, right, it gives you a great starting point that you can go off and do something else with, right? Wordsmith this, like, so one of the things like the multi-pass stuff, like, okay, I love this, but it's too wordy. So I can just say summarize in a sentence. And it will go off, it will take that, it will come back with a much more condensed version of it. Okay, and this is just, here we go, right? I tried to do the gist of it. Now this was off something that it created, but it could have been any other thing you're trying to summarize, emails, bug reports, whatever, if you're looking for patterns and trends. But again, just basic OpenAI stuff. Where it starts to get more interesting for us is things like this, right? Write a boost, for example, function that deletes all files in a given directory, all right? So now we go ask it to do that. And maybe if I remembered, I would have known, oh, yes, there's file system. Okay, where are the docs on that? Okay, I got to go find that. I go off and find it. And, I'm able to do it, and I can do it myself. But look, within seconds, it came up with an implementation in order to do that. So maybe this isn't right. And that's the other thing you got to trust but verify, right? You have to really treat it as something that you're not quite sure if it's doing the right thing, but it may give you ideas that you didn't have otherwise, right? I didn't have to go off and remember, oh, it's in file system, right? And so it just created this for me. It explained what it did and why that happened. So now, let's say I don't trust it. And I say, OK, write a unit test. I'll say, write a CXX-based, if I can actually type, unit test for this. Now, we know unit testing is the least fun thing that any developer wants to do. Maybe it's a head of documentation of things, but so if we could leverage OpenAI, who as Jerome was saying, doesn't get tired, it's got the stamina, right, to write a unit test and gets me like most of the way there, well, now I can take this and I can use this as my unit test. Again, it's my starting point. Something that might have taken me a lot of time to think about, I now have a starting point that I can go from. So boom, we're now generating unit tests with this thing. OK, let's say that, you know what, C++, it's dead. I want to have it be written in Python, OK? So now write in Python. And it goes off, and it deletes, writes the same code in Python, right? So now we have just translated a function from one language to another language. And we'll talk about this in a little bit, but if you're a company with NetApp that has, say, like a large amount of Perl code, and you want to move over to Python, yeah, you can have developers do it. but it's so expensive to have them sit down and do it. If OpenAI can help you out with it, then it's a really, really valuable thing to have. So again, that's kind of like a high level of, so this is the playground, and we put people in the playground and we say, hey, go off, use this to try to understand what's there. And people have done some pretty cool things about that. So, and we'll cover that in a second. So we have that playground, but we also have an API interface to it. So I want to talk about the development workflow and the different places that we found that you can slot this seemingly limited basic capability in there in order to make people faster. Now, I'm just going to say right now, our goal in all this is to understand what this technology could bring to us. So right now, we kind of use it on our internal code. It's non-shipping stuff. But again, the development lifecycle is the same for that as it is for product code. But we're just trying to figure out where we can slot it in. So we've kind of broken the development workflow into these different types of boxes, right? So you have the beginning when you're trying to research, right? Like what am I trying to solve? What does it mean to add support for NFS v4, for example, right? What is that even, right? What is that thing? So you could start to talk to OpenAI about that. What is that? How is that different than NFS v3? What was introduced in NFS v4.1 that wasn't in NFS v4? And you'll get, again, you'll have to verify it, but get some pointers and ways to think about it, right, just in the research phase. And if someone has set something up so that you have an area of, say, code that you're trying to understand, you can write bots against that code in order to say, OK, in this environment, like I just did, how would I, in the NetApp language, test language, how would I do something that creates files, right? So there's the research side. Then there's the code side, which Jerome talked about. I'm typing up my code. I'm fixing my bug, whatever. Oh, man, what was the function that I'm able to use to strip out comments in something? Or how do I write that? And Copilot is magic in that way. And all these other editors where you say, the next function strips out these particular comments. You hit tab, and implementation pops up. Don't trust it, but man, you just got some pointers of how you probably could do it. And it might jog your memory. You don't have to go off Google it or crack up your books or whatever. Similarly, when you're coding, we do code translation. Jerome's going to show us something we call autodoc to document particular functions. We may have functions that were written by people that are no longer here, and you don't understand really well how Perl works. Well, it can tell you what it thinks it does, and it usually does a pretty good job. I showed you unit test generation, analyzing logs. It's pretty good at saying, well, this looks like to where the problem is. Again, not perfect, and you can refine it, but that's a start. And then finally, the review stuff. One of the things that Jerome is working on is like a review bot which focuses on certain areas. So it may be bad to say, hey, OpenAI, review this whole thing and have it give you something back. But if you said, can this be made more efficient? Could we document this better? Could you come up with better names for the variables that I used? The review bot is actually pretty good about that. And then finally, when the stuff is deployed, if you have a product or an API you're giving to a customer, maybe having an interface where they can talk to an AI to ask questions about how do you do different things. I have ONTAP. How do I create a volume that has NFS v4, right? And then finally, when things go wrong, can we summarize bugs? Can we suggest fixes? And can we create things that help us go through some of the hard and expensive processes and slim them down? So the playground itself for us has been incredibly, we've got a lot of traction on it inside. And it can answer some technical questions, but we've even had people use it for things like, I think there was one about how do I write a Valentine's Day card for my fiance or something like that, and it comes up with an idea. And I love that experimentation, right? Try that. Come up with different ways to do it because that may lead to something else. But we've, like the slide says, we've had places where people have some text, maybe they're not native English speakers, rewrite this in English in a better way. And so that's great. That's a huge help. There was another one that I saw where someone was like, here's this API. Can you explain it to me in my native language, right? So there might not be docs in Chinese or Japanese or whatever, but then it was able to translate that and come back. So there's a whole bunch of cool stuff. We've got 10K queries a week, about 400 unique users, and people are really latching onto this, which is fantastic, which is just what we want. And so, okay.
Oh yeah, I'll talk about BrewBot. So models, however, only know what was in their training data set, right? So they know nothing about your own internal knowledge. So we have this project called BrewBot that augments or models, I think it's GPT-4 that they use it with internal tool documentation, right? So it will gather documentation from various sources, whether it's our older wiki site or Confluence these days, or even internal web pages. And it will store that up, chunk that up, index all that, and then uses what's called RAG, retrieval augmented generation techniques, using LangChain, maybe I'll mention it again, and a semantic search in a vector database. Anyway, it augments the knowledge that GPT 3.5 or 4 has with the knowledge or own internal knowledge. And now it's able to answer questions about our own tools, right? And so we have, this project is ongoing. It's been ongoing for a while. You'll find online a whole lot of libraries and tutorials to do RAG stuff. And our experience is that your domain knowledge part is only as good as your domain. As your knowledge. Right? And so, in order to have a good domain knowledge bot, you need to have good internal documentation. And we're hoping here that by having an interface like a chatbot, people are going to be more willing to write good documentation. There's a bit of a catch-22 problem here, where people write documentation and they don't know if anybody reads it. They don't know what questions people have, and then the quality probably suffers. And we're hoping that by having a chatbot that can show them feedback, right? Because the BrewBot has feedback up and down. I liked it, I didn't like it on each answer. That then documentation owners realize what's missing and then start improving the documentation. And little bit by little bit, we solve the bad documentation problem with a better interface. So again, in order to do that, we found that your particular bot needs feedback gathering and analysis. That's a critical piece here, right? If you just throw all of your pages at the bot, it's unlikely you get a good result. It's garbage in, garbage out, right? And then, so you've got to solve multiple problems at once here. And the way to do this is to, when you have a large company like NetApp, is to create this and collaborate with domain experts. To find people who actually own those tools, onboard their content, show them when users liked or didn't like the answers, and have them act on the results, right? So if a user asked a question, got a bad answer, well, was it because of the bot? It's really the case. It's usually because the documentation itself was missing critical information. So that, we have a whole interface here that provides that information back to the domain experts and hope that they will fix it and get immediate feedback on whether the answer is now better now that they fixed the doc. This is ongoing. We're learning a lot here. Turns out that, again, if you go online and look for RAG stuff, whether it's LangChain or Llama Index is another well-known library that does this, they focus a lot on the techniques themselves, assuming good documentation. But it turns out that that's not the main bottleneck for these type of tools. It's really the quality of the source material. There's a lot of lessons here for us. I'm going to show you a demo of this here, Autodoc. We mentioned it a few times here. So Autodoc was one of the very first tools that we created. It generates function documentations for Python and Golang right now. So you can do that. You can get to a 90% solution pretty easily on ChatGPT, right? But what Autodoc does, what we realize, is that developers are finicky beasts, right? They want their documentation exactly right. They want the same spacing everywhere. They want the same column, right? They don't want a dash, right? So they want the same format. And they don't want to have to copy-paste stuff back and forth between different interfaces. So Autodoc is a CLI that allows for bulk function documentation with a very common format. And we're expanding right now we're expanding to other languages. Another cool thing here about Autodoc, and I put an example, is you'll see in the middle of the screen here, there's a function hash and then a very long string. So if you're going to do bulk documentation of files, and you have, let's say, several hundred files, You don't want to have to redo that too often because then the price goes up, right? And so what the function hash does here is it captures the states of all the code that goes below, in this example, source SMS pretty printers, right? And then the tool automatically detects whether the code has changed at all since the last time the documentation was generated. If it hasn't changed, the tool does nothing. If the code has changed, it regenerates the documentation. Right? So it's a cost-effective way to keep your documentation up to date. Yeah. Okay. I'm going to show it to you. I'm going to show you a Python example because that's what we have actually. Yeah, I'm going to load a slightly more interesting one here. There you go. All right, so I'm going to load a file. It's one of our example files, and it has as soon as it does it. Let me fail. All right, you have to reload it. So I'm going to load here an example of a class with two methods, and then I'm going to show you how it documents both pretty quickly. This relies on ChatGPT 3.5, which is both very cheap and very fast.
Which one was it?
The last one, yeah, this one right here. I didn't. Get it again. It's not the one. And then I'm going to play around here with some of the settings. The same thing, yeah, just do a load here. Perfect, all right, excellent. So this is my class. This deals with an elastic group. It will wait for the readiness of some cloud resource here, right? So there is a constructor, the init function, and then the wait for readiness method. So really, all you got to do in the web interface, right? Remember, there's a CLI interface and a web interface. So in the web interface, all you got to do is just click document to get started. The tool will detect the functions, send them one at a time, and create documentation. Right? And you'll notice here a few things. So first, it did it, right? And then it was able here to detect, right? It read the code of the function. Let's look at the init one. And detected on its own that even though HTTP proxy and HTTPS proxy are not documented in the function signature, it was still able to detect that those are actually arguments of the function, right? So it's pretty smart. And then the other one, yeah, again, function that's a little more complicated. It was able to accurately describe what it does, accurately list the arguments that are in the signature, so it's a little easier in this case, create the hash, and so on. Something that our users have found useful is that tests are usually much larger bodies of text, bodies of code, right? And so what sometimes people want is they want a list of steps. They don't just want a summary of what the function does. They also want a list of steps. And turns out that that's something that OpenAI can do pretty good here. So I'm going to create some steps for both of them. It's not going to be very, very interesting for the constructor, but it's going to be more interesting for the other one. Right. There you go, right? So I was able to read the code and create 4 steps that are pretty accurate in this case, right? So this is a very contrived example. Imagine this, especially on tests. People like to do this on tests. It describes what the test does and create logical steps for each of them. So it's a perfect way to get started.
So next one. Oh, okay, that's me. All right. Yeah, so I talked about this a little bit before, but we have this situation where NetApp been around for 30 years. We have a lot of code that was written in Perl when Perl was really, really popular. There, it is harder to find people to maintain that. Harder to, maybe Perl might not have all the latest libraries and things for where we're trying to go, in different technology areas. So one of the early things we played with was this Perl to Python translation stuff. And even on Codex, which was one of the beginning models, it did a pretty good job of moving stuff over. GPT-4 is even better. The sticking point and the place where we would probably grow this is where some of these, the Perl calls our internal libraries that are written in Perl. So we need to do the trick that Jerome was talking about, where we actually pass in examples of how you would call the Perl libraries with Python, because it's not just pure language translation from A to B, right? You have to say, oh, if you were calling the internal NetApp libraries this way, when you want to do it in Python, you have to do it this way. So there's so much potential here, but again, a lot of the times, if you get the 90% solution and the developer can work on it, you've just saved them time, right? And they concentrate on the harder problems. So, and we talked about this just a little bit, but the thing that we're looking for is to have the biggest impact as soon as we possibly can on this. And the in-editor suggestions that GitHub, like Copilot does, and the other tools that you're showing, like Microsoft has studies that show, now granted it's marketing stuff, but we've seen this internally too, where developers not only become faster at completing tasks because they don't have to worry about what the syntax was or things like that. It will put the stuff in there. The Copilot people say it helps you with the easy problems, and that's like right on. But it also makes developers happier because they're not spending their time screwing around with, oh, what was that API call? I can't remember, or whatever, right? And so you still have to do all the hard stuff yourself. But it will accelerate those things that are maybe easier. And I actually find in my day job, I have to do a lot of those easy things. It's not so much my work isn't writing the code, it's thinking the big problem and splitting it down. And once you've done that, Copilot can actually help you a lot. So the last thing, and I showed you an example of this, is the unit test generation. We have our own internal libraries to do test automation, and the team that has worked on that generated this CLI-based thing called AutoUT, which goes off and it takes that and generates the unit test for this. Again, needs to be validated by the developers before they get checked in, but it's able to generate a lot, and most of the time it's accurate and correct. And for that little bit you have to review and tweak, hey, that's not a problem, right? So we actually use this quite a bit in order to validate those libraries. And right now I think it's focused on just Python. We'd like to expand it to C++ because OpenAI doesn't care. It can handle that. And again, the bar isn't perfection, it's just usefulness. What can we do faster? How can we move faster? And this is one way of doing it. So, okay. So this is you.
Yeah. So GPT-4 is a generalist, right? It's able to help you. It cuts your learning curve in languages that maybe you're not familiar with, right? So one way to have it help you is to have it review code in a language you're not too familiar with. And we've seen people do that, where they will copy-paste their JavaScript code, for example, here, and then get advice on how to write it a little better, right? To be more JavaScript-ish or TypeScript-ish or whatever language they're currently using. And we also worked on a tool called ReviewBot that take this a little further. It will actually insert comments in a review request, or internally here we use review boards. Or So here's what we discovered is OpenAI is good at a certain type of review comments, right? So you may already have in your companies here automated comments that come in for incoming code changes that are perhaps based on static analysis, right? So you can go pretty far with static analysis. Is it formatted right? Is there, anyway, there's a number of aspects or type of code reviews that can be done with static analysis. But OpenAI and AI models in general allows for something that's slightly above that, right? So I put some examples here of stuff that does work. Things that, may be pet peeves of mine, for example, right? So you can ask OpenAI to look at code, maybe function by function, and make sure that the variable names or the function names or the class names are descriptive. It would be hard for a human to code that up, right? But an AI has no problem doing that. It will tell you not only what variable or function or class name is not descriptive, but will also suggest what it should be instead. Right? And then ReviewBot here is just the glue code that inserts those comments back into the review request. Another thing that OpenAI is good at, or AI in general is good at, is something that is definitely a pet peeve of mine, is for loops that could be list comprehensions in Python, for example. The same thing, that would be pretty hard to code up as a human. I wouldn't know how to start. never seen that done as a static tool, right? The third one could be done with the static analysis, right? The missing type hints for functional arguments or functional return values in Python. That's something that is a bit more could probably be done with static analysis, but OpenAI will actually provide suggestions. Right? It will tell you, oh, you're missing type hints for this particular arguments, and here is what it probably is, based on the entire code that you just read. Right? So we're pretty excited about that. All right. Another tool we have internally is something called DevBot. So again, like I mentioned earlier, models like GPT-3 or 4 the only knowledge we have is about what was in their training data set. So we don't know anything about your own code base, right? But engineers work in your code base. So how nice would it be to have a bot that knows how to talk or how to manipulate your libraries or this particular repo and so on. And that's what DevBot is about. The team that works on that internally, again, uses RAG technique. So it's all prompt engineering here, built on top of semantic search to have the bot generate code using a particular set of libraries. And I'll show you a good example here. Oops. And the point is to cut down on the learning curve for new engineers, right? As they come across a new repo. So here is what they have right now. A bunch of those are mostly Bitbucket repos, and it's different teams' code bases, right? And so that's DevBot, and I'm showing you here the autocode section because that's what's interesting to us. And so in this interface now, I can ask a question, and it will answer in the style of here, particularly it's the ONTAP API. It's a very specific subset of our testing code. So I can say create a volume, which is a pretty common task in tests. And it will answer, again, using, in this case, GPT-4. It has ingested all of this particular code base called ONTAP API, and hopefully it comes up with an answer on how to create a volume. And if not, well then, you'll be exposed to, what you quickly get exposed to is when things don't work. Okay. I'll try again one more time. Just so you see it.
All right.
I believe it's not completely vaporware.
That work?
No.
Maybe we need to read.
No, no.
No. Okay. Yeah, that's cool.
Come on. If not, then you'll have to believe me. There you go. Okay. So again, it loaded the right, we'll call that Pinate, and then did something. So here I switched to GPT-3.5. We would have gotten a better answer with GPT-4, right? Just trigger it's possible.
Okay, back to Okay, so the other thing that's kind of really, really cool, right? So we in general, right, it is good at telling you what you did wrong with your code with a compilation error. So this can happen to us in quite a bit as we're trying to modernize, move from one version of C++ to a different C++ version. We might not be familiar with what's going on. Clang has gotten a lot better about telling you what is broken, but you can actually say, hey, OpenAI, what's wrong with this code? Why did this compilation error happen? And it will usually figure it out and give you the answer of how to actually fix it. So again, none of these things couldn't be done by searching Google, Overflow, reading the docs and things like or Stack Overflow and reading the docs, but OpenAI solves your problem much, much faster and gives you, or at least gives you hints about what you should be looking at, right? So this is just one of those things. It's one-off. Having the playground to be able to do that is really, really helpful. We have a team that's working on automatically detecting that and fixing that and then proposing the things to users as builds happen. But that's, again, kind of in flight. The other final part, this is the final one that we're going to talk about for things that we can do, is a team that stepped back and said, okay, how can we automate the whole end-to-end process, use AI to do what we normally do by hand? So, for example, we might have somebody whose job is to document functions because we know we need that to happen. And today they would get a JIRA assigned to them. They would go and they would work on it, and then they come up with some results. They submit it for review. The people that really knew the code would say yes or no, and it would go in. Well, they said, well, you know what? Can we automate the whole thing end to end? As soon as a JIRA is filed of a certain type, the AI wakes up, tries to do the work for them, submits a review. If it's good, they check it, and it goes in, right? So that is the kind of the end state, right? Everything is completely automated end to end, where it can be, right? Humans need to be in the loop. But for the stuff that's the easy problems, how can we automate that? So one of the things I'll just say that enabled us to do all of these things was having Azure OpenAI as an option for us, right? For NetApp. We were able to have our own instance that had all the security of Azure, that we didn't have to worry about our data going into the general OpenAI models, leaking from site to site. We were able to, this was just a game changer for us. So with this, we were able to lock stuff down and use it on different types of code that we wouldn't have before, because we really feel comfortable with how secure this sort of environment is and isolated for NetApp. So all of that, right? I just want to tell you, these next three slides are what have we learned, and what could you guys maybe take with you and apply it to FreeBSD development, right? The benefits come out in weird ways, in that because you make it easier to try new things, because the tax for writing some idea or script, even if it's a terrible POC, but if you can lower the barrier to doing that, people are willing to try new and innovative things, right? You're like, oh, I want to do this, and you might think, I want to translate this from Perl to Python. Oh, that'll take me 2 weeks. I don't have the time to do it. But if I could knock it out in a weekend or an afternoon, and it's doesn't have to be perfect, but it proves the point, all of a sudden that's a new area that you can get people to say, oh, I want to spend some time in it, right? Similarly, for people trying out new languages that they might not be familiar with, the JavaScript example that Jerome was talking about was from a developer, very smart developer, but had never really interacted with JavaScript. And he would, as reviews come in, he would do his best to review them, but then he would ask OpenAI, well, what is this doing? What's happening here and here? And you begin to have an interactive session with it to teach you how the language works, which is really cool, right? Like, I'm not a hardcore assembly guy, and we had some problem with some assembly thing, and I put it in there and say, what does this do? I got a line-by-line explanation of what it is. Now, I don't know if it's 100% right, but it certainly pointed me to the right direction and the phrases to use and things like that. So if you're just trying to learn something, it's like a better Google, because it knows all your context in order to answer the problems, right? We had a hackathon, a generative AI hackathon. Jerome, can you show them the shirt? There we go. Proof that we had it. We have a shirt, right? And we had lots of people across the company with different job titles, salespeople, marketing people, IT, all trying to say, how can this apply to their job? And that's really what we need for this, because this is really, we believe it's an inflection point in software development. And, that sounds like a lot of hype, but there's just so much stuff that we can do with this. We got to find what works and what doesn't work, but there's really cool stuff in here. There are things, there's technical debt that we've wanted to pay down forever that was always too expensive. This changes the economics on that, right? Like I said, if you can get a 90% solution much cheaper, it enables us to do those things, right? The ideas span different roles, like I said, marketing, sales, they're kind of everywhere they're looking at this. However, right, nothing is free. The snake oil has a cost, right? You've got to use it as a tool, but know that it can be wrong. And that is the weirdest thing about this, is even when we're doing the chatbot stuff, we're spending so much energy validating that what comes out the other end is correct. And that becomes the bulk of the hard part. How do you know what you get out is correct? Do we want to face this towards our customer without having we absolutely don't want to face this towards the customer without having these checks and balances in place. You can do it, right? But it becomes the hard part of the project but if there's a human in the loop already, then you're good. Maybe you just made them faster, right? So the other thing that's weird about this too is it only accelerates some part of the development workflow. So you hear people like, oh my gosh, it'll make everything faster. Well, what happens is now all your time is spent on the really hard problems. So if you enjoyed figuring out how to get this little tiny script to work, well, guess what? That's already done. You now have to figure out how to make it scalable or whatever, right? So it only solves part of the development process, and it just changes the equations, changes the constants and different things, right? Again, you must validate. We believe we use this wisely. We can generate tech docs, we can generate unit tests that basically enforce higher product quality in the same amount of time, right? So there are certain key areas we have to do this in, but if we can use AI to make us faster, that's really where this can get interesting. We can translate code that we didn't think we could and make us more, flexible in the future. So the last thing, and Jerome said it, this stuff is moving so fast that it's very, very hard to catch up. So you can get overwhelmed with that and always go chasing the new shiny thing. And there is a balance, but some of the stuff that was hard when we started is now a few library calls away, right? So be okay with the change, but don't be scared to just say, okay, I'm going to learn, I'm going to try this right now and try to learn something. So we've tried to push people to the off-the-shelf solutions like Copilot because there is a big back end to make sure that you don't get the wrong answer out the other end. You gotta, if you want to have internal models, you have to have hardware and everything. So, that's one of the nice things about OpenAI, itself. It's a service that we can connect to. So that is it. Again, I know that's a lot. I appreciate your time. I think we have a few more minutes for questions. Are there any questions?
Super useful, super interesting, so thanks very much. My question is a little bit boring in so much as the code snippets, etc., that get generated. So, full disclosure, I head up our open source program office, and we're trying to work out how the hell do we use LLMs, etc., and all other AI tools to make the world a better place kind of thing, right? So one of the questions we have is, how can we guarantee the provenance of the code that gets generated? And what is that code licensed that gets generated? And how can we include that? Are there any licensing conflicts with existing code, et cetera, et cetera? So I appreciate it's a boring one, but it's something that we scratch our head on.
So all I can say is talk to your lawyer to see if Gen AI is right for you, right? But to answer some of those questions, and I'm not saying this solves the problem or everything, is where it came from, I don't know. But the question about whether or not it generated something in your product that matches a snippet that exists out in the open source community, there are tools out there that can help scan for that, right? So Black Duck has something that allows you to say, is this matching something that has a problematic license, right? If you use Copilot, they have in the business model, you can say, do not recommend something that matches a snippet that lives in open source, right? Some amount of lines that are there. There are also different solutions that they use, was it the pile? Is that what it's called? And the pile is based on models that are only or a source code that's only permissively licensed, and people can opt out of it if they don't want to be part of it. And so there's people building solutions on that. So I'm just telling those are things that are out there. I don't know if it solves the problem or whatever, but there are people looking at that piece. Yeah.
So I think you already answered most of my questions that I had watching the talk. Very interesting, by the way, thanks. A lot of the tools that you mentioned, like GitHub's Copilot and things like that, you mentioned that you're using a private Azure instance to protect your IP. Are you able to set up and use all of those tools that you mentioned in such a way that you're assured that what people are cut and pasting into these various tools is not ending up in your competitors?
That's what Azure's instance tells us. They promise, Microsoft promises us that we have our own isolated view of the world.
Understood.
Yeah.
The question is more like, are all the tools that you mentioned that you use captured by that guarantee?
Almost all of them, right? Copilot would be the only one that it's a Microsoft service that doesn't have our own NetApp only instance, but everything else is backed by our Azure OpenAI internal, secure pipe to
Right.
that.
Okay. Thanks. That clarifies.
Yep.
To relate to that question, so you said that prompts are never used to train the model, your prompts, but you still have to fine-tune the model with your internal documentation code, no?
No, because that's part of RAG, and what happens is the prompt itself, which can now be up to 32,000 tokens,
yeah.
You make sure you include all relevant information in that prompt, right? So I may say something that's like, generate a Perl function that calls these 5 library calls to do X. And I say, oh, by the way, here's example 1 that does something slightly different. Here's example 2 that you mine and create ahead of time. So this is the prompt engineering he's talking about. And then the prompt you send off is this big honking thing that has what you want to do, right? How it's supposed to look like, the input from the user, and a bunch of examples that have solved similar problems in the past. So the challenge becomes, and this is why you use vector databases, or what is, up front, is to be able to make sure that the pieces that get sent to the prompt are relevant to the problem you're trying to solve.
So, because the use case we were considering is to give a tool like this to our technical support team. But this would need to the model to be trained with some our internal documentation, other cases from other customers and stuff like that. But that would mean that the model has to be fine-tuned with our internal data. So this is something you would recommend against?
Correct. You can go very far without fine-tuning, right? With just RAG techniques. So if you use something like Llama Index or LangChain, you can go very far without having to fine-tune.
Okay.
Right? And so RAG techniques will react faster to your content changing, right? If you have content that changes regularly, you don't want to fine-tune every day. That's going to cost you quite a bit, right? With RAG, your model can learn about the new stuff almost immediately, right? So fine-tuning has a place in that space, but you can go very far without it.
Okay, thank you.
So I think one more question, because we're right up on time.
Okay, 2 questions. First of all, you were saying with Azure pay-as-you-go. Does that mean that the meter's running and you're paying dollars as you're using it?
Yeah, there's some sub-penny cost per token?
Per 1,000 tokens, yeah.
Per 1,000 tokens. And so you just say, I want this, you get it set up, you start sending secure REST calls to it, and based on how much you use and which models.
Right, and you pay for characters you send, and you pay for characters you get back.
Okay. Second question, I'd be concerned on code development or code translation that the model might be introducing very subtle, hard to find bugs.
That is true, but I have that same concern about engineers.
Of course.
Right? So that sounds sarcastic, but the thing is, the same thing that protects us from that, unit tests, peer review, integration tests, all those best practices for software, if you do those things, you'll catch those similar things. You're right. There could be bugs. I could write bugs, right? That's the thing. But if you follow the software engineering best practices, you should be able to catch those things. So
basically, you're not finding that this is a unique problem to the
not to AI. No. We have other things in place to catch that. Yeah.
And remember that AI right now, the sweet spot is the easy stuff, not the hard stuff, right? So it's easier to find bugs immediately in the easy stuff than it is in the harder stuff, right? Don't try to use AI to solve a hard problem. To use AI to give you time to work on the hard problems.
Right. So we're 1 minute over. Let's cancel it.
Thank you, gentlemen.
Thank you so much. Really appreciate it.